Okay, welcome. This is our first kind of official notes lesson from the new chapter, from chapter 5. We'll break it up into a couple parts. We'll start with lesson 5.1, day 1. I'm going to walk you through the introduction to the new chapter and show you some examples. And you can check out, we'll even look at the assignment and make sure that everything's clear. So chapter 5 is all about systems of linear equations. 5.1 specifically looks at solving systems, linear systems, by graphing. So the first couple things we got to look at, we're going to look at checking solutions today. And then really parts 2 and 3 we'll look at as far as the day 2 part of the lesson. So just as a very, very quick review, I have this part done for us. Graphing equations on the same line. So just quick review or on the same plane. So graphing, here's one that we see in slope-intercept form. We've seen so much of this year that if I have the y by itself, we know we can look at it and see there's my slope, there's my y-intercept. So to graph it, I started at 0, 8, started up here, and used my slope and went down 4 over 1, down 4 over 1, down 4 over 1, down 4 over 1. The second line was not in slope-intercept form, so I had to put it in slope-intercept form. Subtracted 2x from both sides, kind of just left it out front there, and then had to divide by this negative that was with the 3. So divide by negative 3 in all 3 spots. They canceled here, so that left us with y. The negative 2 over negative 3 was positive 2/3. And then 18 divided by negative 3 is negative 6. There's my slope, 2/3. There's my y-intercept, negative 6. So to graph it, I started at 0, negative 6, and went up 2 over 3, up 2 over 3, up 2 over 3. So that's just a straight up review of graphing. But one thing that we notice here when we graph 2 lines, we've never really done that before, where we graph 2 lines on the exact same graph, we can see that they intersect. And it looks like I was trying to be as accurate as I could. It looks like it intersected at 3, negative 4. They both kind of hit that spot. Can I check to see if my answer is correct? That's what this work is. That's kind of our first part, is I can check solutions. We haven't even talked about what a linear system is, but this is going to be kind of the work that you're going to be showing. So I'm taking that point of intersection that it looks like they intersected at 3, negative 4, and I'm plugging those into my 2 equations. So I look here to I'm just calling this line 1. I took a negative 4, which is my y coordinate, and plugged it in for y. So that's where this negative 4 came from. This negative 4 was already there, but then next to it I plugged in a 3 for the x, so that's where this 3 came from. And then the 8 was that was the y-intercept. I simplified it. What's negative 4 times 3 is negative 12, plus 8 is negative 4. You could do that on your calculator, and I got negative 4. I got a true statement, negative 4 equals negative 4. So I know that this is a solution to that equation. Line 2 was in a different form, but the process stayed the same. Wherever I saw an x, I replaced it with 3, so this became 2 times 3. And then wherever I saw a y, I replaced it with negative 4. So this became negative 3 times negative 4 equal to 18. Simplify the left side, did it in a step, so 2 times 3 was 6. Negative 3 times negative 4 was positive 12. When I add 6 plus 12, I got 18. Therefore, this was also a solution to that equation. This makes, to this point, 3, negative 4 a solution to a linear system. We'll get into that right now. So let's take a look at the notes. I've said it 3 or 4 times. What is a system of linear equations? It's basically 2 or more linear equations with the same variables. So this kind of fits that bill. It's 2 equations, and they both have x's and y's. Both have x's and y's, part of the same kind of problem. A solution, which again we kind of just talked about a little bit already, is an ordered pair. So an x and a y, just like we saw right here, that basically is a solution to each, depending on however many are. We had 2. It could be 2 or more, we set up here. it's a solution, and it has to be true in all equations, not just one. Okay, so I take, that was kind of the check part of it. What does it look like graphically? We saw it. The graphs of the equations should intersect at that ordered pair. So this is kind of like almost like the finished product where we'll get to by the end of the lesson. Is I'll give you a line, say graph it, what is the solution, and check it. Okay, we'll break that down a little bit today, just for today's lesson, and just kind of focus on the checking part of it. What am I looking for? What should I be seeing? So here's the first part, checking solutions. Let's see what we got. We've got the directions. They tell whether the ordered pair is the solution of the system of linear equations. So let's just make sure we're on the same page with the vocab. I've got a system of linear equations. Here's one equation, here's two equations, and then I've got an ordered pair, the 0.25. Now it's tougher because I can't see the graph. I don't know. Is this where these two lines would intersect? Maybe. So we have to check it. I'm essentially going to plug this 2 in for x here and here, and this 5 in for y here and here, and make sure and see, do we get 7 for the first equation? Do we get negative 11? Here's what I need to see for your homework. Your homework looks exactly like this. Same first set of directions. This is what the homework looks like. 0, negative, so you got your systems, and you got points, your space for your work, which I'm about to show you how to do. So for the first one, I'm going to take, you can just set it up, label it. Let's just call the top line 1, or equation 1, line 1. Okay, and this one's pretty simple. It may not hurt to just call this my x and call this my y, so I don't get confused. And essentially for this one, yeah, there's my x. I'm plugging in a 2. Show this step. Don't just say, oh, the answer is 7 equals 7. Plug in a 5 for y. And see what we get. 5 plus 2 is 7. 7 equals 7. It checks out. I am definitely not done. Because what did we say like 2 seconds ago? The solution has to work in each equation. So the fact that I've got one that's true doesn't mean anything. If it doesn't work here, then I'm going to say, no, this is not a solution. I got to check it out. So let's do it. So for line 2, it's a different form, so we got a little bit more work on this one. 2 times my x, which is 2, minus 3 times my y, which is 5, and we should be equal to negative 11. Okay, so let's see what happens. 4, and I'm going to go really negative 3 times 5, which is negative 15, or just 4 minus 15. We're seeing what we get. 4 minus 15 is negative 11, which it checks out. So yes, 2, 5 is a solution. Okay, that's the work that I have to see. So for your numbers 1, 2, and 3, you cannot just circle yes. You can't just have a minimal work. I'm looking for what? A couple lines of work. Okay, I'm going to run through the second one just real quick so we can kind of see the process if you needed a second example. Similar setup. This one's got a 0, so, and then plus these ones are in different forms, so it's not going to hurt to see and check out this example. I'll do the same thing. We're checking. The directions haven't changed. That's still my x. That's still my y. I'm checking, is this a solution to these two equations? Okay, so for line 1, stay organized, show your work. Plug in a 0 for y, so now we're kind of starting on the left side here with just a 0. Negative 2 times, let's see, my x is negative 2, so watch your negative signs. We're inputting it here, and negative 4. So I get negative 2 times negative 2, which is 4, minus 4. And I think this first one is going to check out. 4 minus 4 is 0. It works. Let's change colors here. Line 2, same process. plugging in a 0 on the left side, because that's what y is. So I'm replacing my y with a 0, equals x, I'll replace them with -2 plus 4. So I do the right side, -2 plus 4 is 2. Uh-oh, 0 does not equal 2. This is not true. Therefore, we got to say that -2, 0 is not a solution. Okay? So, that's what you're doing for the first 3 problems of the homework. You're checking an ordered pair to see if it's a solution. Showing your work. You can use your calculator for these portions. Okay, not just this part of it though. I want to see your plug-in. I want to see your work. I'm not asking for a lot. The only other part of the homework, we'll skip ahead here to kind of the next section, example 2. Now we're seeing some graphs. The directions say use the graph to solve the system of linear equations. Check your solution. Okay, so we're kind of baby stepping it here a little bit. Now the graphs are made for you. You can see 3x minus 2 equals 10. Which line is that? To be honest, at this point, we actually don't necessarily have to know. It turns out it would be this one. This would be my x plus y equals 0. The point is, it really doesn't matter because all we're doing is checking the solution. I feel like the graph is done for us. That's probably the hardest part for most of us, is making the graphs. If we have the graphs made, I'm really going to check, what did we say a solution to a system was? On the notes portion, we said the graphs of the equations in a system intersect at this ordered pair, at the solution. So I'm looking for this point of intersection, which has the coordinates of 2, -2. So I'm going to jot that down here, just right next to it. 2, -2. So other than just that part right there, identifying the point of intersection, the work that you're going to show here is all right here. Checking your solution. Okay? Which essentially we did on the last 2 examples. Okay? So it's kind of making that connection of where would we check? Where would this come from? The previous examples just kind of gave us a random point, 2, 5, -2, 0. Now we can see it from a graph that, okay, hey, that looks like my point of intersection. I need to check that. So let's do the exact same thing here. Your work is almost going to look identical. Here's my x. Here's my y. I'm going to just call that top one like we did a second ago, line 1. And I'm going to substitute 3 times my x coordinate, which is 2, minus 2 times my y coordinate, watch your minus, your negative signs here, equal to 10. We're going to simplify it. 3 times 2 is 6. -2 times -2 is +4. And we can see that we get 10 equals 10. So 3 lines of work there. Substitution, simplify left, final check. Second one, let's change color here. Line 2. X, we're just going straight up x, 2 plus my y, which is -2, and we should be getting 0. So in one like this, I'm only going to have 2 lines of work. 2 plus -2, there's nothing else to simplify here. 2 plus -2, or 2 minus 2 is 0, equals 0. It checks out. My solution is right here, 2, -2. Oops. All right, one more here, just stay with me, just to kind of run through it one last time. Again, for the directions, we're basically checking, use the graph to solve it. We solved this system, believe it or not. We solved it just by looking at it and seeing that and checking it. So we're going to solve this system. X plus 2y equals 8, 3x minus 2y equals 8. What? To solve that, we're looking for that point of intersection. So, do the same thing that we just did. Let's call this, just put that point on there. What are the coordinates? Be careful, you don't mix this up. 1, 2, 3, 4. 2. So those are my coordinates right there of that point, 4, 2. I'm going to put them right on there. We might as well just put the x and the y with it right away, because we know the only work we have to do now is to check. Does this work in the first line, first equation? So I'm going 4, because that's my x. That's all I need. There's nothing with it. Plus, now I got to account for this 2, though. 2 times, what's my y? 2 equal to 8. So checking it out, 4 plus 4. Yep, I think we're going to be okay. 8 equals 8. Checks out. One more here. Why not? Line 2. I'm taking, this one's got a little bit more substitution, so 3 times my x coordinate, which is 4, minus 2 times my y coordinate, which is also 2, and we're hoping to be equal to 8. So 3 times 4 is 12. Show this kind of this in-between step. 2 times 2 is 4 equals 8. 12 minus 4 is 8. 8 equals 8. I like it. I think we're okay. So we would just follow up and say that, what was our coordinates? 4, 2. The point 4, 2 is the solution. So there we have it. I'm going to show you the homework right now. It's going to look identical to the 2 types of problems we did. We already went over these first couple. The next set, you've got 4 graphs. That's it. That's the homework. It's 7 problems. Okay, so I'm expecting it to be completed neat, showing your work, checking them out, following up, saying, yes, this is my solution. No, this is not my solution. Your options for submitting it. Okay? If you're lucky enough to have a printer, I'm not. I don't have a printer. So I would have to work on a separate sheet of paper, okay, where I would kind of copy this down. And, you got a little bit more work. That's not that much, so you're still going to just jot this. Number 1, you don't have to write the directions. Put your name on it. Put the heading on it. On a sheet of notebook paper, you're going to copy the original problem down, and you're going to do what we just did. If you have a printer, that's great. You can print it. You can do it right on there. You do your work right on the sheet. It still might be tight for spacing, but those are your 2 options to do it. To submit it, you're going to take a picture. So for me, I would have to zoom out so I could see my whole assignment. Take a screenshot. Now again, I'm not going to be doing it on the computer. It's got to be pencil and paper. Do not use Google Docs to try to attempt to complete this. It's not going to work. You're not going to get credit for it. Do it on pencil and paper. So for me, I would have paper in front of me. I'd be doing all these problems by hand, writing them out, take a picture of my completed work, attach it to the Google Classroom. Don't email me directly. So we're trying out the Google Classroom stuff. I think we can get it to work. The other classes seem to be figuring it out. I'm sure you're doing it for a few other classes. That's the lesson. Give it a shot. We'll come back and finish up with 5 part 2, or 5.1 part 2, which really all we have left is kind of the graphing part of it, which we've done a lot of. But we'll finish these notes up as part of a day 2 lesson, okay? So go back, rewatch any parts you have to. If you want to check your workout, I'm giving you till Monday to complete this. So I'm trying to make it easy and give us some time to do all this stuff. So there's your day 1 assignment and notes.